Okay. For those of you at home, I just got glared at. You missed it though. It's over. It's not funny anymore. All right. If you're at home, you missed all the fun. Okay, so we'll go ahead and start out with number one. So number one, you know this is, you're going to factor something out of every term because every term looks so ugly. You know, like if they're really simple, it's kind of like, well, I don't know, maybe I got to factor the whole polynomial. But when every term is so ugly like this, you can definitely factor something out. So let's deal with the coefficients first. 2, 4, and 6. What's a common number I can pull out of all three of those? 2. 2 is the largest. Okay, how many x's can I pull out total?
2.
1. Right? Remember. If there's only one x,
I'm sorry, I didn't see that one.
Yeah, it's the minimum number, right? We had 2 over here, but we can only pull 1 out of this term, so 1's the maximum. What about the y's?
1.
A single y, yeah. And that's because we had this single y back here, so that's all we can really pull out.
They can't see that, just so you know. We can point to that. They can't see that. We walk up and point to that.
Oh, goodness. This single y right here. Thank you. I forget that a lot.
I know.
Obviously. Okay, so now we just write what's left if we were to divide each of these terms by what we just pulled out. So if you divide 2x y to the 4th by 2xy, you just get y cubed.
Y cubed.
All right. The same thing with this next one. If you pull out 2xy from this, you have 2. The x is gone. The y drops down 1. Yeah, it turns into a squared instead of a cubed. This last one, 6 divided by 2 is 3. We pulled one of the x's out and the y out. So that's all.
Is that it?
No.
Let's see now. That's it. Yeah, and the way that you can kind of tell is, first of all, you know, there's no common terms that we can factor back out because we've already tried that, right? Obviously.
We can't pull anything more out of that.
And here's a cube. We haven't learned how to factor cubes in this class.
Right.
And even if we did, there wouldn't be really a way to factor out a cube with an x at the end. So yeah, that's prime. Yeah. I should actually probably try and make more problems that it's a little more easy, obvious that they're prime. Because this one you might have to mess around with for a while to figure it out. But yeah, that's prime after that. So this would be your final answer. Okay, the next one. This is the case where the terms are not super ugly, right? And so that's a pretty good indicator that we're going to split it up into 2 binomials.
Yeah.
The other indicator is this little number right here. It's a second-degree equation, which means we have to factor it to solve it. Or we have to do a binomial factor. You know what I mean? Yeah. You can't just factor out a single term or a single factor from every term. You got to do the full factorization. So first things first, I know this is going to factor into 2 binomials with x as the first term in each. Now, I notice I have a plus 5 over here. So these are either both plus or both minus. The middle is a plus, so they have to add to get a plus sign. Yeah, so you have 2 plus signs in here.
X plus, X plus.
Right. 5 is prime, right?
Right.
Yeah.
Yeah, there's only one way to do this, and that's 5 and 1. Yeah. So there we go. And if we want to check our work, we FOIL this guy out and just make sure that it equals. Yeah.
X squared plus 6x plus 5.
Exactly. Okay. Here's another one of those examples where we have a second degree, so we're going to need to factor this in the kind of more confusing way. We do have a coefficient out front, and so we're going to do the process where we multiply the coefficient on the first term by the last term. So I make my little table, and I say, I say 9 times 2, that equals a positive 18. And so what I'm looking for is pair factors of 18 that add to the middle term, 9. Yeah, exactly. So let's see now. 1 and 18, that doesn't work. Do you guys know? Somebody was about to say something. 6 and 3, exactly. 6 times 3 is equal to 18, and 6 plus 3 is equal to 9. So we have a winner. So the next step, this is the crucial step, right? And this is the one
show.
Yeah, you definitely got to show this step. And also, this is the step that a lot of people kind of forget, and they try and do a traditional factoring. But now we want to split this up and factor by grouping. So the 9x comes straight down. And then we split up the middle term into these two factors that we found.
Plus 6 plus 3.
Yeah, plus 6x plus 3x
Plus 2.
plus 2. Exactly. Now we're going to do a little factor by grouping here.
Yeah.
All right, so in the first grouping, it looks like I can pull out a 3x. That's going to leave me with a 3x plus 2. And that's added to, I can't pull anything out of there, and I don't want to pull anything out because that's my matching factor. Yeah, this factor matches this factor. So I'd pull this factor out, 3x plus 2, and then I write what's remaining, 3x and plus 1, right? Don't forget this part, guys. Don't forget the plus 1.
Plus over there, it's just remember it's a 1.
Exactly, yeah. Yeah, whether this is a plus or a minus sign here,
There's a 1 there.
yeah, there's going to be a 1 out there. All right, so that is the sort of the more complicated example, right? Remember? Sorry, I should do this
Just remember,
right here.
we have to remember
Multiply.
to split that 9x up, right?
Yeah, multiply first and last terms. Find pairwise factors of that number that add to the middle number. Once you find those factors, you actually split up your middle number into those factors.
I'm acing this test.
I'm telling you, if you got this stuff down, you're going to do fine on this test. I'm telling you.
I'm just putting it down there. I'm laying it out.
I'm not lying to you, man. All right. So now we're asked to solve these problems, right? This is like one step further than factoring these problems, and it's an easy step at that. So in order to solve this guy, we first have to factor it because it's a second degree equation. So I go ahead and write out what I know this is going to look like in its factored form.
I only have
Equals
a
0.
minus first.
Yeah, we have a -6, which means we're going to have a positive and a negative as our factors. So we're looking for two factors of 6 that differ by 1. Obviously, it's 2 and 3.
Yeah.
Sorry to spoil. Spoiler alert. All right, and so I put the plus sign on the 3 because the middle term is also a positive. So the larger factor needed to be positive. So now I just solve each of these factors for 0. So I say, what would make this first factor equal 0? That would be if x equaled -3. Exactly. What would make this second factor 0? If x were equal to plus 2. Yeah. So these
Our answers.
are my solutions. All right. So real quick, let me just do an extra little bit. So if you guys were to factor something out and it was, and these were the factors, and I think we went over this before, but let's do it just one more time. Right, suppose you got to the end and your factors were that. And so there's coefficients in front of those x's. Then you actually need to set up your equation and solve for 0 if you can't see what the answer needs to be. And so for this first factor, I would say 2x plus 1 equals 0. What does x have to be? I would subtract 1 from both sides. 2x equals -1. Divide both sides by 2. X is equal to -1/2. Right, and so that would be one solution. Yeah, and so it's not always as easy as just looking at it and saying it's the negative of that. You got to actually solve it if it's something a little weirder. So 3x plus 5 equals 0. We want to know what x that happens at. So we would get 3x equals, subtract 5 from both sides, divide both sides by 3. We get x equals -5/3. Right, and so it's tough to see that if you're just looking at this.
Go all the way.
Yeah, so sometimes, if it's not a very easy factor, solve it for 0. And then you'll be confident with your answer. All right, number 5. Oh, goodness.
Look at this.
So this is an evaluation problem.
Oh my
I
God.
think it's pretty small. So remember, and I mentioned this in my solution set too. I told you guys, like on the first day, evaluation problems are going to be in every single exam. All you need to do for an evaluation problem is wade through all the confusing stuff, plug something in and calculate. At the base, that's what it always is. So for this one, it says the concentration of a drug in parts per million, F, in a patient's blood X hours after the drug is administered is given by this function. What will the concentration in the patient's blood be after 0.5 hours?
So X 0.5.
That's it, yeah. X is 0.5. You just enter it into each and every one of these, and you solve, and that's your
Plug and
F.
play.
That's what evaluation is, yeah. Just plug and play. So, you guys all got your calculators? Throw it in there. Let's all see if we get the same number for
Juan
this.
stole mine.
One. Darn it, Juan. Right, and this will be good practice. You know, you'll see if you don't get the same answer as everybody else on this, you might want to check it 2 or 3 times when you're in the test. You all right, Tessa? We'll just... What? Are you okay?
Oh, this is really nasty.
Oh.
Oh.
That's
like, oh.
disgusting.
It hurts me.
Good job.
Acne causes you pain and it sucks.
I just got lost all concentration. And away we go.
How do you put in the powers on calculator?
It's tough to see. There's a little caret that looks like this.
Look here.
Right, and so if you want to say x to the 4th, you would type, or if you want to say 3 to the 4th power, you'd say 3 caret 4.
Okay.
I'm just gonna rely on you guys to put up.
There's no way we're going to get the right answer on this.
Yeah, this is like... And Gabe, if you're listening,
Right? Gabe's probably watching at home. He's already got it.
yeah,
He's yelling it at the screen.
he's like, this is the way I would do it.
Oh, I shouldn't write that up there yet. What'd you guys get? Did anybody get an answer yet?
174.
All right, 174. Do we have a second on that? I ended up with 53.0625,
That's our second.
which I feel like that's a more likely answer because there's no way all this stuff ended up with a whole number, right?
No,
It's possible, though.
I think it, I don't know, I don't have calculators, so. I
Just shut up.
just gotta go back home. Take it next semester.
Right? I don't feel like it today. Next semester, maybe.
Yeah. I gotta take my Louis with me.
I'm the one that needs the most help.
Yep, nope,
No, you didn't.
nope.
What'd you get? You're our last great white hope.
Come on, Jarrett. You can do it. I believe I'm correct. I believe it's 53 point,
With those numbers down below, I think you're right.
yeah. So, if you want to get your answers correct on the test, you're going to want to check this 2 or 3 times, honestly. Yeah. You want to do it on your calculator. You want to do it like this, where you write them all down individually. Like,
Right.
check your answers on this, right? The original problem is not tough. It's just plug and play. So the toughest part is making sure it's correct.
Correct. So we would say our concentration in the patient's blood is 53.06 nanograms
Yeah, after 0.5 hours.
after 0.5 hours.
Yeah.
And that's just how you state that.
That's it. Yep.
Clearly, you're gonna have to teach me how to plug it into a calculator. 'Cause clearly I don't-
We'll do that on Monday.
You know?
Clearly that's gonna be on the test.
That, yeah, it absolutely will.
The gothic kid stare. Oh, I love these ones. You know, they're fun.
I can't tell if he's serious or making fun of me with that one because, like, I do say that sometimes. Oh, I love these ones.
But I actually do.
Good, good. I'm good.
I was being sincere.
You're picking it up then, good. All right, so on these ones, just notice we have a division symbol in
Yes, and when we
between.
flip the second two.
Exactly, we flip them, we just multiply by the reciprocal. So we have x minus 1, 4x plus 8, multiplied by
Plus 2.
x plus 2, 2x minus 2.
That's so awesome. Fun.
All right, so now on the next step, let's see now. I'm going to factor we'll take this one step at a time.
Factor 2.
Yeah, so on this factor right here, the 4x plus 8, I'm going to factor a 4 out of that. So that'll give me x plus 2. And then on this factor, 2x minus 2, I'm going to factor a 2 out of that. And that's going to give me, whoops, yeah, x minus 1.
X minus 1. Then we just cross those out.
Yeah, looks like we can cancel the x minus 1s. We can cancel the x plus 2s. Is it 4 or?
1. Oh,
Oh, 1. 1 with 4 plus 4 times 2.
Yes, that's the one.
I got it.
That is it. All right, so so remember, when we're dividing, we just multiply by the reciprocal, and then you want to try and cancel anything you can. All right, number 7. So let's just do method 1 first. Remember, there are 2 methods to deal with complex rationals. There is method 1, where we do the numerator and the denominator separately. And then there's method 2, where we come up with an LCD that works for the whole problem, and we just multiply all terms by that. So let's do method 1. Method 1. So I have 5 over x minus 2 over x squared over 2 over x squared. So method 1 basically says we just treat this separately and we pretend that this is a different problem from this momentarily. And this is a great example for method 1 because the bottom's already done for us, right? This would be more tedious with method 1 if there was an addition or subtraction on the bottom, but it's already done, so actually method 1's pretty easy for this one. So if we wanted to add these 2 fractions together up top, we would have to get a common denominator of x squared. So I'd multiply top and bottom of 5x by x, right? I put my negative sign back in there. That was convenient. So now I have 5 over x squared minus 2 over x squared all over 2 over x squared. I go ahead and I do my subtraction on top. 5 minus 2 is 3. 3 over x squared over 2 over x squared. Now I'm in that situation where I can just flip this bottom guy and multiply. So I have 3 over x squared times x squared over 2. The x squares will cancel, and I get 3 over 2. All right, so that's method 1. Method 2, we have just 2 over x squared over 2 over x squared. Yeah, for this particular one, method 1 was easier, you know, or more convenient anyway. So method 2, we come up with an LCD that works for the entire expression, which in this one it's the same as part 1. So we pick out all our denominators, we write them on the side, x and x squared, and then we notice that one of those denominators completely contains the other. So that's the LCD. So now we multiply top and bottom of this overall fraction by the LCD, x squared and x squared. When we distribute this in, we end up with 5 times x squared over x minus 2 times x squared over x squared. And then when we distribute into the bottom, the x squares just cancel and we get a plain old 2. Now we go ahead and simplify everything that we can. So we cancel an x here and we have 5x. We cancel our x squares here and we get minus 2. Over 2. Right? Yeah, 5x minus 2 over 2.
Actually, no, get rid of the x. Remember, because x squared.
But
5 minus 2.
no, because this is a single x right
Okay,
here.
Okay. You're
Right, yeah.
Yeah.
And so what happened?
I thought it was 3 over 2.
It is.
What did I do wrong here? Something went wrong. 5x minus 2.
Over, under, I think,
But I thought we minus 5, you didn't, 5 minus 2 is 3.
Yeah, you gotta get rid of that x, right?
Yeah.
The x squared. The 5x squared should be just 5. It should be 5 minus 2.
But it shouldn't be.
What?
So we're not gonna come up with 3 if it's not.
That's not the way math works.
Game.
So, okay, all right. So let's
Let's try method 3.
Oh, I didn't do method 1 correctly. That's my problem. You guys are supposed to catch me when I do this.
Yeah.
So, you see this over here where it's on top, it says 5 times x?
Yeah,
You didn't bring it
5x
over.
minus
There
2.
should be an x right here. Yeah, so it should be 5x minus 2 on top. Let's go and erase a bunch of this stuff.
Hey, at least we caught it.
Yeah. Right, one problem later. Okay, so we had 5x minus 2 on top here, so it doesn't work out as nicely as I wanted it to. 5x minus 2 over x squared. The x squares do still cancel though. Cha-ching, cha-ching.
So
And we get
5x minus
5x minus 2 over 2, yeah. There we go.
Look at that.
And look at that, this is correct too. All right, so there we go. There's a good lesson on why you should check all your work. All right, so here we go. Here is a rational equation instead of an expression this time. So with rational equations, we always want to come up with an overall LCD and multiply through by that number. Right? And like basically, whenever we see an equation with fractions like this, first step is to clear all the fractions. If you do your first step and there's still fractions there, something went wrong. So to clear all the fractions in any equation, I just have to recognize their denominators. We have an x and we have a 4, and we need to find the common denominator. Obviously, those don't have any factors in common, so we just multiply them together to get our LCD. Now I'm going to multiply every term by the LCD, 4x. When I multiply into this first term, the 2x, I get 4x. Actually, I get 8x
8x.
over x. That is equal to 5 times 4, 20x over x. And then when I distribute into this last one, I get 4x over 4. Right? And now when I go through and I simplify things, there should be no more fractions left. So I cancel my x's, that leaves me with an 8. I cancel my x's again, that leaves me with a 20. And then I cancel my 4's, which leaves me with an x. All right, so now I'm going to go ahead and subtract 20 from both sides. So I have 8 minus 20, that gives me negative 12. That is equal to negative x, which tells me that 12 is equal to x.
Yep.
Okay. Oh, and of course, something that I always forget to do on these problems, even when I was a student, I forgot to restrict any values, right? Remember, when we're dealing with equations, when we have variables in the denominator, we have to pick out we have to pick out values for those variables that they can never be, right? So if x were equal to 0 here, the world would explode. So we don't want that to happen. So right up here in the beginning, we say x cannot equal 0. And then when we find our solution, we make sure that that solution is not the restricted value. This is not. X cannot equal 0. So yeah, this is good. If our solution were x equals 0, this problem would have no solutions. They don't exist.
And we just state that.
Yeah. All right. Anybody got any questions about that one? Okay. Ooh, yay. All right, so this one it's the same exact thing as the last one was. We just have a little bit of extra work to do when it comes to our denominators. So right off the bat, we see this is a rational equation. We want to get rid of these denominators. We don't want any more fractions. So we list our two denominators, t minus 3 and t squared minus 9. And then we write those in their prime factored form. T minus 3 is already prime. T minus 9 splits up into t minus 3, t plus 3. This guy here completely contains the factors of the other one, so that is my LCD. So I'm going to go ahead and multiply this into each term, t minus 3, t plus 3. All right, so when I multiply it into this first term, I get 5 times t minus 3, t plus 3, all over t minus 3. When I multiply into the second term, I get 30 times t minus 3, whoops, t minus 3, t plus 3. And then I have t squared minus 9 on the bottom. I'm going to write it in its factored form so you can see why I'm canceling everything. T minus 3, t plus 3. And then that equals 1 times my LCD again. So that just equals my LCD. T minus 3, t plus 3. Okay. Now I'm going to go down and I'm going to erase this stuff on my LCDs. Do you guys mind?
No.
Okay. Get rid of all this junk. Junk, junk, junk. Okay, so now I'm going to go through this. I'm going to cancel all my like factors. Cancel that guy, cancel all of these, and then there's nothing to cancel on the other side of the equals. So what I have left is 5 times t plus 3 minus
30.
Yeah, straight up 30 equals t minus 3, t plus 3. All right. So now I did my whole first step. There's no more fractions, and so I go about solving this like I normally would, which there's a bunch of legwork to do.
Yeah.
So I go ahead and I distribute my 5. I just start simplifying things right off the bat. So I have 5t plus 15 minus 30. On this side, I'm going to get t squared minus 9. We already knew what that was equal to, right? So it's not that much legwork. So now I want to get all this stuff over to one side and then factor it out. So I'm just going to consolidate these two. So I have 5t minus 15 equals t squared minus 9. I'm going to add 15 to both sides. That's going to give me 5t equals t squared plus 6. Then I'm going to subtract 5t from both sides. That's going to give me 0 equals t squared minus 5t plus 6. And we can see that this is going to break down into a pretty easy factorization. But I forgot to restrict my values again. Hold on. So stupid. Okay, so I forgot to restrict the values. You want to do that right off the bat. So remember, this t minus 3, this means that t cannot equal a positive 3, otherwise we break rules. But remember what this t squared minus 9 breaks down into. Breaks down into t plus 3 and t minus 3. So t cannot equal plus or minus 3. All right, so those are our restrictions. Now let's go back down to the problem where we were at. So now to solve this,
0. So it is a solution.
what's that?
It'll work.
Yeah, it will. Yes, it's going to work. Yeah, we have a second degree polynomial here, which means we're going to have to factor it out and solve those factors. So we get 0 equals t as the first term and t is the first term. How does it factor out? What do you guys think?
Is it t minus 1, t plus 1?
Not t minus 1, t plus 1. Otherwise, there'd be a minus 1 back here, right? Remember, those two numbers, they have to multiply to give us positive 6. right? And so what two numbers?
2 and 3.
2 and 3, right? Yeah. And if they're both negative, then they add to -5, which is what we wanted. -2, -3.
Yep.
So this tells me that t is equal to a +2 is one solution. T is equal, what? Did I screw something up?
No.
T is equal to a +3 is the solution for that factor. Now we got to go back up and check our restrictions. Our restrictions said t can't be plus or minus 3, so this solution is invalid. That's not a solution. T equals 2 is the only solution for this.
That's a lot on that one.
Yeah, it's a bit, but it's not that bad.
I got it. Remember to write the restrictions.
Right. Just for a quick poll, would you guys rather have 10 problems on the exam or 15?
10.
And this is why I ask, because currently I do like 10 problems. But if you get one problem completely wrong and you have no idea how to do it, you get a full letter grade off. Right? Well, you get to cross one out, of course. But then the next one, you get like a full letter grade off. And I feel like, you know, like sometimes it's a really simple thing that you guys
Like
just
the
forgot
one-
how to do.
Like my last test.
Maybe.
Yeah, I got it.
You know, so you guys like the fewer problems.
Yes. It depends what problems you're going to give us. If there's some factoring.
Well, my guess is that what I would do is I'd probably switch from 10 to 15, and I'd basically have like 4 or 5 problems that were
Kind of similar.
very simple. You guys definitely want the 15 problems.
All right, let's do 15.
Because I would do like
Well,
5
technically
problems that are like
16.
very basic, and then I'd do like 10 problems that are like the regular
What's our
test.
basic
So would you
and-
technically do 16 because
Yeah, I'd do 16 and I guess an extra problem, extra credit.
Well, I
Yeah.
can see this. We learned.
I mean, so we have to cross one out.
Yeah, you still get to cross one out. I wouldn't get that away. I love that part.
Well, we learned a lot in all these chapters about factoring. So, you know, if we're
So they're going to be easy.
okay. You mind if I?
All right. No, this next test will probably still have 10. I'm just, you know, in the future,
Oh.
I like to change things on the
You're the boss.
Have you made the test yet?
No. Like I said, I just look at the old test. I look at what I'm showing you guys right now, and I change things a little bit. All right. So this is a work problem. We all love work problems.
Actually,
And it's gotten worse.
this won't be on.
So work problems are actually cake. Like as long as you remember the formula, work problems are so easy. So work problems, this is the general formula. 1 over A plus 1 over B equals 1 over T. Where A is the time for person 1 or water pipe 1 to do the full job. B is the time for entity 2 to do the job, and T is the total time, right? So most problems, they give us A and B and they ask us to solve for T. The only variation you're gonna run into is if they give you A and T and ask you to solve for B. That's it, like, you know, these are the 3 values you'll be given. One's always missing, solve for that missing value.
The answer, so it'd be 1 over 12 plus 1 over 30, so the answer would be 1 over 42.
Not quite. And I'll show you why. You started on the right path, but we did our addition of fractions incorrectly, right?
I'm totally lost.
So the pool can be filled in 12 hours if water enters through a pipe alone, or 30 hours if water enters using a hose alone. So we'll just consider the pipe A and the hose B. So we have 1 over 12 hours plus 1 over 30 hours equals 1 over T. And we just have to solve for T here. We do that using the same technique we use on all of the rational equations, right? We need to find an LCD, multiply through, and then solve for T.
6.
So I have 12, 30. Is 6 my LCD? I think you're right. Yeah. So 6T is my
6T.
my full LCD, right?
Right.
So I have 6T and 6. Wait. No, it's not 6. Sorry, Kevin, I let you.
You let us down the wrong hole.
Wait, what? Okay.
No. We were looking. You completely grabbed the least common divisor, right? Which is good, but we were looking for the greatest common divisor.
It's 3.
No, it's not 3. So it's.
3 is less than 6.
Remember how we do this, right? Yeah. The LCD should be greater than or equal to both the denominators, right? It should never be less than, because then we'll never cancel those fractions.
Okay.
So, Kevin. He's all dejected. Okay. All right. So we have 2 times 2 times 3 is the prime factorization of 12.
Oh, yeah.
Yeah, they see, now you got it. And then we have 5 times 2 times 3 is the prime factorization of 30. Circle 1. Write it down. 5 times 2 times 3. And then we fill it in with, am I?
No.
No, I got it. Oh, I'm missing a 2 in the final.
Yeah.
Yes. I am missing a 2.
Yes.
This one right here, so I add that in there. So that gives me 5 times, that gives me 60, right?
Yeah, we're somewhere around there.
All right, and of course we have a t, so it should be 60t. There we go.
So 60 T hours.
60t. So, yeah, so here we go. So 60t gets multiplied into every term. I'm going to go ahead and erase this stuff down here. Do you guys mind?
Yeah.
Boom. It's gone.
Gone.
All right. Okay. So now I'm going to go ahead and multiply this 60t in everywhere. 60t over 12 plus 60t over 30 equals 60t over t. Now I cancel and simplify things. This is 60 over 12 is equal to 5. 60 over 30 is equal to 2. And then my t's cancel on this side just to give me a straight up 60. Now I can combine my like terms, and that gives me 7t equals 60.
Divided.
Divide both sides by 7.
8.571428571.
8.57. so t equals 8.57. So this is saying that
It will take.
if the 2 intakes are working together, it will take about 8 hours and 8.57 hours to fill the whole pool, right?
Yeah, 7 minutes.
Now, since this is a work problem, we just want to check to make sure that that answer even makes sense, right? If one hose does it in 12, the other does it in 30, it would make sense that our final answer were lower than both of those, right?
Yeah.
And so, yeah, the answer makes sense. We're going to go ahead and go with that. Right? If we ended up with t equals 19, we'd be like, what? That doesn't make
Or
sense.
42.
Yeah, that's not going to make sense.
That's a big pool.
All right, so yeah, for those work problems, just make sure.
Are they talking about like the big, deep, cold pool or the warm one or both?
It doesn't matter.
It's not even real.
And that's one of the other things about these work problems, and you'll see this on the homework. Like, a lot of times they'll say stuff about the job that doesn't matter. And so, like, on the homework,
That's
I think
why
I have
put
like,
all the extra.
Yeah.
Just the equation.
and so like with this problem, if they wanted to do that, they'd be like, Ketchikan recreational pool is 2,000 gallons or something like that, and they'd like give you a bunch of information that you didn't need.
Or if you-
All you need to know is that they're doing one job, right?
If
It
it's
completes
just like-
one job. That's the important part. It doesn't matter the square footage of the job, the volume of the job. What matters is they're completing one job.
And then we plug in the right equation.
Yeah, that matters too. So this one, you'll want to put this one on your note card,
Yeah.
definitely. And put the description on there too, right? I think it says, suppose person A does the job in however many hours, yada, yada, yada. You want the whole thing on there.
Go.
Alrighty.
Shot down now.
You sure did.
One more thing about these problems. Sorry, I didn't mean to scare you. It's so 1 over 12 plus 1 over 30 equals 1 over t. If the problem said, how long do the hoses, if the problem said that one of these hoses was an outtake, right? Like it was taking water out of
Oh, yeah.
out of there. You just put a negative in the middle. That's all. That's the only difference.
Okay.
Yeah. So if they're working against each other, one's going to be a negative. All right. Number 11.
No. Billie Jean Flow.
Yeah, there's no 12th problem. Okay. So Billie Jean Flow walks. You don't like my
Concilio.
Cooper Colby Concilio. In the time it takes Cooper Colby to walk 7.5 miles, Billie Jean Flow walks 13.5 miles. Find their speeds. Don't they sound like 80s speed walking superstars?
Yeah. I was thinking
Right?
of Gene Jackson.
Yeah.
Michael.
All right, so with distance problems, I'm going to go ahead and set up a table. That's what I always like to do for distance problems. Along the left side, I'm going to list my two things that are competing or racing against each other. Billie Jean and Cooper Colby. I'm going to say Billy and
JF and Triple C.
Cooper. Billy and Cooper. Across the top, I write my D equals ST equation. D, S, and T. And if you're used to R being there instead of S, that's fine.
Oh, these ones.
Oh.
All right, so I draw out my matrix.
Speed and time.
Yeah, and then I try and fill in any values in this matrix that I can. So, let's see now. Billie Jean Flow is walking 4 miles per hour faster than Cooper. So,
4x.
if we call Billy
Billy gets 4.
X, then we call Cooper 4 miles per hour faster.
X plus
X
4.
plus 4.
X plus 4, exactly.
It says in the
Wait,
time
isn't
it
that
takes
supposed to be backward? Isn't that the other way?
It's the other way around.
Because Billy walks faster than Cooper.
Concilio.
Oh,
walk.
good.
It takes.
Thank
Let's get
you.
this right on the track.
Right? Let's not let's not rewind this one.
7.5, so for distance, Cooper it's 7.5, and then for Billy it's 13.5. So it's
Good.
so 7.5x.
Kind of. Okay. Let's keep filling out our little matrix here, right? So the key to knowing like how to solve this particular distance problem, like there's multiple variations of these distance problem, is that it takes them the same time. In the time, right? So it's the same time. And that's really the key to solving this. Yeah, so I'm gonna represent that with a capital T. Time.
For time.
Because it's the
Time.
same, there's no variation.
Yeah, exactly. So then I'm going to take a look at my D equals ST equation. So if I isolate my time for each of these, Billy and Cooper, I can set the corresponding equations equal to each other. So T in this equation is equal to D over S. And that's just if you divide both sides by S, right? So Billy's time is Billy's D over S. Cooper's time is Cooper's D over S. So we have,
0.5 over x plus 4.
yeah, 13.5 over x plus 4. That equals capital T. Capital T also equals 7.5 over x. Exactly. Now that we know that all these things are equal, we can just get rid of that big T in the middle.
13.5. Then we want to flip it, right?
Not quite.
Dang
Right? So this is a rational equation. What we want to do is clear those fractions. That's what we always want to do, right? 'Cause fractions suck. We hate them. So x times x plus 4 is our LCD, right? That's just because these LCDs are prime already. So I multiply everything by that. X times x plus 4. X times x plus 4. All right, go and erase this guy. So now my x, oops, that was a little more canceling than I wanted to do. All right, so my x plus 4's cancel right here, and that leaves me with 13.5x, right? And then my single x's cancel over here, and that leaves me with 7.5 x
Plus 4.
plus 4. Right. All right, so now I distribute the 7.5, and I get 7.5x plus 30?
Yes.
Yeah.
30.
And so now we subtract
Good.
7.5x by both sides.
And what do we get if we do that? Do we get 5x?
6x
6x.
over 30, which equals 5.
X is equal to 30 over 6. Tessa, you are blazing fast today. All right. There we go.
Good job, Tessa.
X equals 5
Damn.
is the answer that we come up with. Does that make sense?
Yeah.
No.
So Cooper's speed is 5.
5 miles faster.
Oh, so yeah, so Cooper was going 5 miles per hour.
And
Billie
Billy
Jean,
was going 9 miles an hour.
yeah, which I don't know if any of you guys run or anything like that, but
But yeah, it's how moving.
Billie Jean Flo was flying.
Flo,
That's a
flying.
fast lady
Billie
right
Jean
there.
Flo flying.
No wonder her name's Billie Jean Flo.
is flying. He's flying while singing
BJFF, Billie Jean Flo flying.
Okay, and that was our review class. So,
And we get
like I said, I'm about to pass out. Oh, yeah, that's one thing I forgot about. If you guys are watching this at home, you didn't get the practice sheet. I'm gonna. I'll try and put this. I'll try and put this on the website so that you guys can download it.
Nope, should have been.
But
Download it.
if you don't have it and you're watching this, just come to my office and get it.
Or you can get it from Bluey.
Or I'll do some with Kate too.
I was gonna say, download it on the free UAS app today, or you can just get it from Bluey, okay?
Yeah, and so I believe, I can't remember if this one was the exact test from last year or not, but it's very similar. You know, and there's a few of these, I just make a lot of these up, and so there's a few of these that don't end up nice. Meaning like,
the problem.
yeah, like the first one, like, you know, like you think you can take the problem further, but there's really just a bit like one step that you can do and then it has to be done. I don't know, it's just weird.
What you talking about, Willis?
Like the one, so the one that a lot of people had problems with was number 6. I'm just going to show you this to you guys because it's so stupid.
All right.
So x minus 1 over
this is,
3. Yeah, you remember this one, right?
Yeah.
It's just, and it, like a lot of people didn't get it right because it was such a stupid problem.
You gotta flip it.
Yeah, so you flip it, right?
Right.
And so you say, okay, I'll just flip that. X minus 1, 3x plus 10. Right? And then you flip it, and then you multiply it together, and you get x plus 2 over 2x minus 1. But that's it.
That's the problem.
That's the end of the problem. And everybody was like, that can't be it. And they tried to simplify it further, and they broke rules doing it. And so it was like, it was terrible. Like, I almost, yeah, I felt so bad because I wanted it to simplify.
But that's
but
great because we're supposed to know that.
Well, yeah, but I'd like you to learn it on a homework problem instead of
Right.
an exam. So, that's it. You guys, thank you for being patient.